A large stone is dropped from the tall building, let's say, in because it is dropped, so initially its speed is 0, and you have to identify the graph. You have to see what should be the speed time graph after 1 second. So I'm going to show you its position, different position as it is falling in a presence of air. What should be the speed time graph? Let's analyze what is the effect of the air resistance on this falling stone. So these are the different positions at which we will see that how the air resistance is acting. For example, in the very start at this position on the stone, air drag is almost zero. So Fd is equals to zero, and all the force is acting is equals to the weight. So you can say acceleration is maximum because the resultant force is maximum. Now on the second position, as you see, because as it is falling down, velocity is increasing, speed is increasing, and the drag force depends directly proportional to the speed. So it is directly proportional to velocity. So the weight is not changing, it is still Fg, the same value. Now what will happen, because upward force is increasing, that's why acceleration is decreasing, because resultant force is decreasing. That's why acceleration is always equals to, according to Newton's second law, F net over m. So acceleration is decreasing because the resultant force is decreasing. But what about the speed? Speed is increasing because it is gaining more and more kinetic energy. At the position 3, let's assume that the at this instant the drag force has increased up to that extent. Now it is equals to the downward force, and now this body has achieved the terminal velocity, means it is has started moving with constant velocity, which is called terminal velocity. So if we analyze this in the form of graph, so we can say in the whole of this procedure up to 1 second and even later, what happened, the velocity speed was increasing but acceleration is decreasing. So the graph should be increasing speed but at the decreasing rate. Reason is that because if you see at any point, the gradient of the graph is equals to the acceleration, and this tangent line is becoming less steep, which is evidence of this fact that acceleration is decreasing, that we saw here. So option D is the right answer, increasing at the decreasing rate, means acceleration is decreasing.